Hello everyone and welcome to this our video today in our YouTube channel. In today's video we shall be looking at how we can answer this question I have here on screen. Guys, this question was proposed to me by one of my subscribers. The question reads that the position vector of a particle P at time t seconds with respect to the origin O is given by r equal to, we have t squared plus 1 in the sense I plus t cubed minus 2t in the sense j meters. Then the A part is saying that we should find the velocity vector of P at t seconds. Then B, we should find the speed of P during the third second of its motion. Then C, we should find the acceleration of P at t second. Then D, we should find the time in bracket S, that's the times means it can be one time, it can be two time, and so on, at which the velocity of P is perpendicular to its acceleration. Then this one, of course, is an omission here, guys. This is supposed to be E. Okay, so I'll just change that. I'll just hardly change that. This is supposed to be E. I don't know. This is supposed to be E, guys, not E again. Okay. The E part is saying that we should hence locate P at the times. That's the times. That is this time above. All right. Now, guys, let's see how we can start scoring these marks. All right. The first part wants us to find the velocity of the particle at t seconds. Okay. Now, guys, please keep in mind that in this case the position vector has been given, namely the displacement as a function of time. It has been given. So, for us to get the velocity of this particle at t seconds, all we simply need to do is to differentiate the position vector, because keep in mind that the velocity is simply given as the derivative of its position vector with respect to time. So, guys, in this case, we should keep in mind that the velocity of P is given as dr by dt. We have our r already, so we just have to differentiate with respect to time. And, guys, if we differentiate that so well, we are going to have dr by dt, which is the same like our v, which is the same like this our v here, which is the same like, if we differentiate t squared, we have 2t in the sense I. Differentiating 1 gives us 0. Then plus differentiating t cubed gives us we have 3t squared. Then differentiating minus 2t simply gives us minus 2. All that in the sense j meters per second. Alright, guys, so this is the answer to the first part of the equation. This is the answer to the first part. We've differentiated already, and this is the velocity as a function of time. Okay, now let's look at the B part. The B part wants us to find the speed of P during the third second of its motion. So, guys, let's keep in mind that the speed is simply given as the magnitude of the velocity. So, guys, let's keep in mind also that the speed is the magnitude of its velocity, like I said. So at time t equal to 3 seconds, because the question said during the third second of its motion. So when the time is 3 seconds, we simply plug in the time t equal to 3 in this our equation, so that after plugging in, now we can now find the velocity when the time is 3 seconds. Then now from the velocity, now we can simply get its magnitude. Great. So now in this case, guys, if when t is equal to 3 seconds, if we substitute 3, now we are going to have our v to be 2 into 3 in the sense I, plus this 3 into, we simply plug in our t to be 3, we have 3 all that squared minus 2 in the sense j. So, guys, if we simplify this expression now, we are going to have our v to be 6i plus 25j, all that meters per second. But keep in mind that this is not the answer to the problem. This is not the answer, because this is rather the velocity. So we need to get the speed by simply taking the magnitude of the velocity. So, guys, like I said, keep in mind that the speed is the magnitude of the velocity. So it is just simply given as the square root of the sum of squares, which is going to be 6 squared plus 25 squared. And, guys, if you simplify that so well, you should have an answer of the speed to be given as the square root of 661 meters per second. Great. So guys, this is the answer. And an important hint, the question along the line did not ask you to put it to some amount of decimal places, right? The question rather asks you for the speed. So square root of 661 now is the right answer to the problem. Okay, it's exact. So this is how you have to leave your answer. Okay, now the next part wants us to get the acceleration of p at t seconds. All right, now guys, also keep in mind that the acceleration is given as acceleration, we can call that a two dots, that's a double dot above. Those of you further maths, I'm sure they are so familiar with this symbol. It's given as dv by dt. dv simply means we differentiate the velocity again one more time, which they seem like d squared r by dt squared. This our v is simply given as what, dr by dt, right? Now differentiating v again simply means that we are differentiating dr by dt again, which is going to be d squared r by dt squared. So this is where we have to differentiate. So we're simply coming out and differentiate this 2ti, which is simply going to give us just 2i. Then differentiating this 3t squared simply gives us 6t. Then differentiating negative 2 gives us 0. So guys, if we do that so well, we are going to have our a 2 dots to be the same like 2i plus 6t, all that in the sense j meters per second squared. So guys, this is our acceleration. This is the acceleration in which we're asked to find. Alright, so let's see if we can get the next let's see if we can solve the next part of the equation, guys. So this is the data in which we are going to use to solve the next part. This is the data we are going to use. So guys, please don't forget to subscribe and like this video, because that does motivate me enough to create more content, and I'm going to keep doing that for you guys. Guys, please follow our Facebook page. We are follow our Facebook page, guys. We are going to leave the link in the description below for your convenience. In our channel, we offer courses in mathematics, further mathematics, additional mathematics, chemistry, physics, biology, and so on, computer science. Anything you want to learn, guys, we are here for you. So we can only help you to achieve that if you're subscribed to our channel, guys, and you've given this video a like. So please make it a habit to always like all our videos, and most importantly, guys, share it with your friends so that they can have access to good content like this. Thank you very much. Let's dive straight into it. Okay, now the next part wants us to find, this is not supposed to be a, guys, this is supposed to be d, then this is supposed to be e. Yeah, this is supposed to be d and this is supposed to be e. Okay, it wants us to find the times at which the velocity of p is perpendicular to its acceleration. Okay, now guys, this question now is also trying to test our knowledge of vectors, how much knowledge of vectors we have, because we know that for v to be perpendicular to a, that therefore means that the dot product between v and a should be equal to 0, because we know that the angle between two perpendicular vectors are what, 90 degrees, right? And the cosine of 90 is what, 0. Good. So we should know that for the velocity to be perpendicular to its acceleration, that therefore means that the dot product between the acceleration and the velocity should give us 0. That therefore means that, guys, if we now, this is our acceleration, right? This is the acceleration. This is the acceleration that we have it here. Then the velocity is what we have here. Great. This is the velocity. So we simply copy everything here. We dot the two of them. This is my dot here. That should give us 0. So guys, and know that we dot corresponding components. We don't just dot as we are multiplying out brackets. We dot corresponding components. You take 2i and you dot with 2t, then take 6t and you dot with everything you see in this bracket here. So guys, if we dot that so well, we should have an answer as 4t plus 18t cubed minus 12t equal to 0. If we now factor out 2, or better still, if we add for these two like them, because we have 4t and we have minus 12t, right? So if we add them up, we are simply going to have minus 4. Here it's supposed to be 8. Okay, good. Yes, 4 please. 4, because if we take negative 4 minus 12, right, that gives us what? Negative 8. Dividing the whole expression by 2 simply gives us 9t cubed minus 4t equal to 0. That's great. So now if we factor out t, now we are going to see that we have our first t to be what? 0. If you solve this guy, you have your first t to be 0. Then we are going to have our t squared to be equal to what? To be equal to 4 over 9. That therefore implies if we take the square root now, we are simply going to have our t to be 2 over 3. Guys, keep in mind that the square root of this guy, we are going to have plus or minus 4 over 9. We are simply going to have plus or minus 2 over 3. But we know for sure that time is never negative, right? Time is always positive. So we are going to reject the negative value and accept the positive value. So this is the positive value we have. Great. Alright. So we have the time to be t equal to 0, or we have what? We have t to be equal to 2 over 3 seconds. Alright. So these are the two required times. This is the answer to the first. This is the answer to the D part of our question. Let's look at the last section. The last section simply wants us to locate P at these times, at these 2 times. Now guys, to locate P, we simply go back to the position vector and we substitute the times. We have t to be 0 and t equal to 2 over 3 to the particle is located at this point. So now if we put our t to be 0, we are simply going to have our arrow to be equal to I meters. So we are simply going to have, because if t becomes 0, this is 0, this is 0, this is 0, so everything here is 0. This guy becomes 0, so we are simply going to have 1 times I gives us I, then meters. So that's the point. So that is exactly where P is found. You can go further to say that since the I component represents it simply represents the X, so you can see that T is located at the point whose coordinates are 1, 0. Great. That's also a very brilliant answer to give. Alright. Now if we now substitute our t to be 2 over 3, guys, if we substitute our t to be 2 over 3 expression, we are going to have our arrow to be 13 over 9i minus 28 over 27g, all that in meters. Hence now we can conclude that P is located at the point whose position vectors are r equal to I and r equal to over 9i minus 28 over 27g meters.